Carolina Bays are something that we have in the United States. The Carolina Bays are huge holes in the ground. They were punched into the ground about 12,000 years ago approximately at the Gothenburg Magnetic Reversal. I think we'll eventually find out exactly the reversal. But in some places, they're called Carolina Bays, they're called Maryland Basins, they're called Grady Ponds, they're called Salinas in Texas because rainwater collects in there and then evaporates and becomes salty. But and I just found out in the last couple of weeks that Australia is pockmarked with what look like Carolina Bays. But here's the thing. Now, these are not just little holes in the ground. Some of these depressions in the ground are an acre in size, but some of them are as much as 6 to 7 miles across. So some of these holes in the ground that were caused by explosions in the sky, some of these holes in the ground are bigger than nearby cities. They're huge.
Maybe that's why people think they were meteorites.
Well, yes, there's
comets.
A book out, Cycle of Cosmic Catastrophes, written by a nuclear physicist, Richard Firestone, and by a geologist, Anthony West. But in their book, they do guess that the Carolina Bays were created by a meteorite exploding in the sky. Now, here's the thing. There are more than 2 million Carolina Bays. I mean, I sure wouldn't have been wanting to stand at ground zero when all of those explosions went off and created 2.5 million holes in the ground that are bigger than nearby cities. And these things scar the landscape from Florida to New Jersey to Texas. And I mentioned, I just had a reader. I didn't know this. I didn't mention this in the book. But I just had a reader send me information about 2 weeks ago. Is he saw, when he was looking at Google Earth and he was looking at Western Australia, he found what looked to be Carolina Bays there. These bays, the reason scientists think that they were created by explosions in the sky, see, I think those explosions were triggered by magnetic reversals. But going with the meteor theory here for a little bit, is that these bays are all elliptical. Every single one of them is elliptical in shape. And you can go on to Google Earth yourself if you have it, and you can see them. They're still there today. Most of them now, if it's in a rainy area, they are like swamps. They're shallow. Even though they may be 7 miles across, they're still shallow. They're only 20 to 50 feet deep. And nobody even knew they existed until about the 1930s. They used to think they're just swamps. But then when they started flying over them, they realized, hey, these things are all elliptical. These are all oriented north and south. They're just so many, and some of them overlap other ones, and so they were obviously created by some sort of explosion in the sky. The thing is, though, I mean, they keep talking about meteors, but in North Carolina, in South Carolina, there are no meteorite fragments that anybody's discovered. But if anybody wants to go onto Google Earth, you can see them for yourself. I mean, if you look at the North Carolina, South Carolina region, and then you zoom in on an area about 18 miles south of Fayetteville, for instance, you'll see 20 of those elliptical depressions in a tiny area, just maybe 12 miles by 9 miles across. And hundreds of them surround Lumberton, North Carolina. But it's just amazing, and that no one has talked about these. I figured everybody in the Carolinas, I figured anybody near a Carolina Bay would just be astounded by this.
So are we due for a magnetic reversal?
I think we could be. And I can't say exactly how soon, but they do occur in a cycle. Is that about 11,500 years ago to 12,000 years ago, we did have what's called the Gothenburg magnetic excursion. 23,000 years ago, we had the Mono Lake magnetic excursion. The difference between an excursion and a reversal is in a reversal, the magnetic field goes south and stays there, whereas an excursion, it may go south for just, say, 500 years and then pops back up. So it's really, truly difficult to identify it in the geologic record. You got to find a rock that comes from exactly that 500-year period. So it's tough to find. But another magnetic reversal occurred about 33,500 years ago. I don't think it's a coincidence that's when the Neanderthals went extinct, by the way. And I don't think it's a coincidence that the Neanderthals appeared on this Earth about 115,000 years ago at the Blake magnetic reversal. There's too many coincidences. The other thing about meteors is I can't imagine that meteors return and attack our planet every 11,500 years in sync with these magnetic reversals and in sync with precession of the equinoxes. I think it's an earthly process not coming from the solar system. Because of this cycle of magnetic reversals about every 11,500 years, we're due for another one. And the other reason I worry about it is that prior to all previous magnetic reversals, our magnetic field strength declined. It kept declining and declining until it reached about 15% of its normal strength, and then, boom, we had the magnetic reversal. Well, our magnetic field strength has declined about 2/3 in the last 2,000 years, since the time of Christ. And the rate of that decline is picking up. The rate of decline is now about 5% per year. So I can't say exactly when this is going to happen. I'm not going to go with the Mayan calendar thing.
I had heard, and maybe this could be corrected, but when I interviewed Dr. Bonnelly in Canada, he said we're losing our magnetic field at 5% every 100 years.
Yeah, is that, I'm sorry, that is correct.
Okay, that's what you meant, right?
That is what I meant.
Okay, good. All right.
Thank you.
So the magnetic strength is getting less and less and less, and this is correlated with excursions or reversals?
In some respects, the word excursions and reversals are the same because it actually does reverse.
Right.
So sometimes I do call it a reversal, but no, the scientists think that the last major reversal occurred about 780,000 years ago at the Brunhes-Matuyama boundary. That's what it's called. And there was a giant extinction then and a descension into an ice age. By the way, that's another thing that happens with these magnetic reversals.
Talk about that.
We do enter into an ice age, it seems like, every single time. But before I forget this, though, there was a magnetic reversal about 640,000 years ago called the Big Lost magnetic reversal. And that just happens to be when Yellowstone exploded as a supervolcano. So that would have caused a major extinction. But it just, when you go back through the record, there are just so many extinctions and ice ages that occur in sync with magnetic reversals. And there are so many jumps in evolution. I mean, I don't think it's just a coincidence that apes and humans branched apart about 5 million years ago at the end of Miocene at a magnetic reversal. I don't think it's a coincidence that Homo habilis appeared about 2 million years ago at a magnetic reversal. I don't think it's a coincidence that Australopithecus, an upright walking creature with a man-like jaw that went extinct about 1 million years ago at a magnetic reversal. I don't think it's it's a coincidence that Peking man appeared about 780,000 years ago at a reversal, or that the Neanderthal disappeared at the Lake Mungo magnetic reversal. There's too many coincidences, and I think all of that goes to the fact that our magnetic field protects us from cosmic rays. It protects us from radioactivity. And when our magnetic field reverses, all of a sudden we lose